بشرفني استضافة دكتور إبراهيم عاصي لإعطاء المحاضرة الثانية بعنوان استخدام الأسفلت المعاد تدويره في إنشاء الطرق فاعلي أداء المختبرات والآثار الشهادة البيئية السيطرة من الماء.
شكرا كثير. يعني انا مفتخر اني موجود بين اهلي واخواني في هذه المحاضره. I'd like to thank the university, organizing committee for giving me this opportunity. I'm speaking in English so that ambassador will be happy and she'll give me the visa easily to Thank you very much. No, I've been to Malta and it's a very beautiful country. Everybody should try going there. It's a very nice country. Yeah, my name is Ibrahim. I'm specialized in asphalt and asphalt pavement. And I always tell my students, asphalt is my blood. So it's a very scarce commodity. That's why we have to try recycling or reusing this material. So the title is the use of recycled asphalt in roads construction, laboratory performance and environmental and cost impacts. As a pavement, it starts from the top. It's the surface, which is the hot mix asphalt. It's a mixture of asphalt and aggregate. So hot mix asphalt is the surface layer. It's a mixture of asphalt and aggregate. It's a durable material and it's very expensive material. Then comes beneath that one is the base, which is a granular base course, which is a mixture of processed aggregate, which is less expensive than the asphalt material. After that is the sub-base, which is also granular. So all these layers, base, sub-base, and sub-base are granular materials. So granular sub-base layer is a mixture of natural aggregate and which is inexpensive. And all these three layers come on the subgrade, which is the natural ground, which is a weak and it's an in situ natural material. So here I have the HMA layer, base, sub-base, or subgrade, due to the traffic loading coming with the surface layer, environmental condition, water, snow, and sun, and with time, cracks starts in this layer. And due to all these cracks, and my layer becomes a deteriorated asphalt layer. And if I leave it with time, it will become very deteriorated. That means that I have to get rid of this layer. The lower layers are in good condition. It's just the upper layer which needs to be taken out. So there are different methods. Either I go to milling, which is just taking out this upper layer, which is the asphalt and aggregate, which is a mixture of aggregate coated with asphalt, or sometimes I go to ripping off of the surface using graders, bulldozers, just take out this asphalt layer. But however, this aggregate coated with asphalt or this ribbed asphalt is a good recyclable material. I can use that material. That's why comes the word reclaimed asphalt pavement, which is a RAP. We call it RAP or reclaimed asphalt pavement. Asphalt pavements are removed for reconstruction, resurfacing, or obtaining access to buried utilities. You have a utility line, you want to maintain it, you take out this asphalt layer. So RAP refers to the removed or reprocessed, because we take this material and we reprocess it. So we take this RAP and we use self-pavement material containing asphalt and aggregate. So I can reprocess it. If it's a blood material, I have to crush it. And if it is a milk material, I have just to resize it, put it in different sizes according to the size. Well, and this material consists of high quality, well-graded aggregate coated with asphalt cement. We usually process this RAP either in central plants or even in the field itself, in the cold or hot in-place processing. Then we use this RAP material, which is very beneficial for both economical, and that's what I'll be showing in my presentation, technical and for environmental. So I'm keeping this environment, I'm protecting the environment itself. So usually 20 to 50% of RAP is used in hot mix asphalts. Hot mix asphalt. However, up to 80% RAP was used in asphalt pavement. Nowadays, even in Japan, 100% of the RAP material is used completely in the resurfacing of the pavement layers. So out of the 90 million tons of hot mix asphalt that are milled and removed each year, 90% is used in highway application in one form or another, including pavement and in the base and sub-base layers and in the filling of the landfills. 1/3 of this 90 million tons is recycled into hot mix asphalt. 1/3, about 30 million, this is just in the United States, 30 million is used in HMA or HMA, hot mix asphalt. Advantages of using RAB: cost saving, because you are using the area, you are reusing the asphalt, which is a scarce material. You are reusing the aggregate, which is coated with asphalt. So it's a protected material that can be reused to the itself. Reducing pavement life cycle cost, because you are reusing a material which is wasted. Reduction in landfill usage, because a lot of this material is used in landfill. Protecting the environment, which is the main cause of this conference, and protecting the aggregate and asphalt resources. If percentage of RAB of mix is lower than 50, usually we use, as I told you, we even about 80% of the asphalt or HMA RAB material. So if you are using less than 15%, you don't need to make any changes to the asphalt mix. Just you take the RAB, you add it to the mix, and you mix it with that. However, if you are using higher percentages, sometimes you need the added asphalt should be softer than the normally used. And sometimes we use some regenerating materials to lower the viscosity or the stiffness of my asphalt by using the rejuvenators in this. So RAB, as I told you, is an aggregate coated asphalt. So the same specification which goes to the HMA goes to the RAB itself. So I don't need any new specification for the RAB. But the only thing, I have to control the moisture content, because when we mill the asphalt, it has all the percentage, all the sizes of the material. So if water comes into it, it's trapped there. So usually I have to control the moisture content of this trapped water. So the recycled asphalt mixture should meet the same specification requirement as required for the virgin mixtures. I did the research in Jordan. I evaluated suitability of materials, so we collected different RAB material from different sources. So the main research objective were evaluate suitability of these materials from milling roads in Jordan to be further used in construction of new roads. Then that collected the RAB material. I optimized the material itself. How much percentage of this RAB can I use it in our roads? Determine and I wanted to convince the government there. So part of my research is determine required modification for the asphalt mixing plants. I want to tell them, use the RAB, and what modification to your mixing plants you should use you should modify to use that RAB itself. Then also my research included constructing a test section for further evaluation for the optimal mix. So the study phases consisted of 4 phases. Phase 1 included collection of RAB material and evaluation of the RAB material and collection of fresh asphalt and fresh aggregate and characterization of these materials. So I collected the RAB from north of Jordan, central part of Jordan, and south part of Jordan. So my research contained 3 samples from different places in Jordan. I did centrifuge extraction to know what's the percentage of asphalt in the RAB material, how much asphalt I have, and the gradation of my aggregate, because I have to mix this aggregate on my mix, so I need to know the gradation of this mix. Then I took the asphalt itself and did rotary evaporation to return my original asphalt and to test it. And I found that because of the passage of time, the asphalt which I corrected from the 3 regions was harder than the original asphalt, which is the virgin asphalt. Of course, with time, with the absorption of this asphalt by the aggregate, it's getting harder, and because it's subjected also to the environment, it's getting harder. So I just evaluated the asphalt itself. I evaluated the aggregate and found some of the aggregate are lower than the specified specifications in the RAB itself. Then I took this material and made I prepared asphalt mixes without RAB, and I prepared asphalt mixes with 5%, 10%, and 15% of RAB to see what is the effect of using RAB in my mixes. So I generated an Excel sheet in which I put the gradation of the RAB material, and it will tell me how much asphalt I should add and how much the size of the aggregate I should add to that asphalt. I made a mix design for the material at different mixes to see how much asphalt I need to add, and checked all the properties of this asphalt mixes. Then I prepared samples without RAB and with RAB at different percentages. Then I compared the performance of this RAB. So I just prepared Marshall mix samples. I tested these samples in static creep, where I put the sample and just put creep and evaluated their performance. And I found that the more RAB I add, it improves the creep properties of my asphalt, because I'm putting a harder asphalt. So with the addition of RAB, I'm increasing or improving the properties of my mix. I tested that at 25 degrees and at 40 degrees. I tested the resilient modulus, and I found that the higher the RAB, I get the better resilient modulus or strength of my material. Because of samples from Irbit, the material will be marginal. It means that sometimes I have to test my material. It's not always that the more RAB I use, the better properties they are. Because if my RAB material is low quality, it will affect the quality of the end product. That's why I have to optimize my mix. So I optimize my mixes. For the Irbit samples, I found that the optimal RAB addition was 10%. For the others, it was even 15% for the other regions. I did the same for the retained specific gravity for the RAB. And at the end, I selected the optimal addition of the RABs. I constructed a test section and came with the conclusions. Even I made a presentation of where to add the RAB in our mixing plant. We have a mixing plant. I can add the RAB after the drying drum, because there are two types of mixing plants in an asphalt. There are either the batch plant or the continuous plant. In the batch plant, here we are heating the aggregate without asphalt. That's why I cannot add the RAB in the heating drum. I can add the RAB after the heating drum, or in the elevator, or in the place where I have the aggregate being weighed, or even in the batch plant there. Then it can be mixed and added and used. So I don't need to do any modification to my mixing plan for the batch plant. Same for the drum mixer. I can just add, because in the drum mixer, I'm adding the asphalt in the drum itself. So I can add the RAB either with the normal aggregate or in the middle of the drum, which indicates that adding this to the drum mixer will not affect does not need additional cost on the mixing plant. I did an economic study to see the effect of the adding RAB onto my mixes. So I did some calculation, cost of producing 1 ton of HMA, hot mix asphalt, with and without RAB. So from my study, I found that on the average, the aggregate cost me $25 per ton, asphalt cost me $410 per ton, and the RAB cost me $5 per ton, which contains about 3.5% asphalt. So I did the calculation for the HMA without RAB. I found that 1 ton of HMA will cost me $44, and I found that HMA with 20% RAB will cost me $37.56. So it was 44 without RAB. Now with RAB, it cost me 37%. It means that adding RAB, in addition to protecting the environment, it will also decrease the cost of the HMA. In conclusions, A mix containing grab should improve creep performance and stiffness values than the mixtures made completely with fresh aggregate and virgin asphalt. Due to marginal properties of grab materials in some areas, inclusion of high percentage of grab might lead to reduction in mixed resistance stresses. Recycled pavements can generally perform as well as conventional pavements, so inclusion of grab will not affect if it doesn't improve it, it just keeps it the same. That's why, in addition to the environmental advantages of using grab, the usage of 20% grab replacements in HDA led to a decrease of 15% on the price of 1 ton of HDA. Therefore, in the region, serious plans should be set up to implement the usage of grab in road construction. Thank you. Any questions? Yes, please. Grab, as I said, it's a normal asphalt because now when we are constructing a road, we'll just get the aggregate and we'll heat the asphalt. Asphalt is coming from the oil itself. So asphalt plus aggregate. So when we are mixing them together, the asphalt. Yes. Yes, because in the refinery, in the petroleum refinery, at the end of the barrel, you'll find the asphalt. So it comes at the end of the barrel. It is that. Because it has a lot of asphalt. Yes, please. Yes.
Duration of the time of the asphalt in the road, is there's calculation of the time, and do we need, like, if we want to do the same thing in Palestine, do we need to repeat the experiment on the asphalt in Palestine, or we can just generalize your data to be used in the other countries around the world?
No, as I said, mainly I want to make sure that the aggregate I use is a good quality aggregate, because if the original road which I constructed has a bad quality aggregate, it means if I use it again, it will ruin my road. So if I use a good quality aggregate, if I use a good quality asphalt in the beginning, reusing it will not affect, and I don't need even to do any research. Just evaluate the properties of my asphalt, my aggregate, and I can use it in my mixes.
Thank you.
Yes, please. تفضل.
بالنسبة للمصانع اللي بيتم فيها إعادة تدوير الأسفلت، بنبحث منها رائحة صعبة ومش منيحة، كمان هي بتؤدي لتلوث بيئة وللمناخ، للانحباس الحراري اللي عم بيتزايد من يوم ليوم. فشو هل يوجد عندكم الدخان اللي بينبعث من المصانع لشيء يعني آلي جديد اللي ما تلوثش البيئة وما تلوثش الجو كلياته في المدن اللي قريبة عليها هي المصانع؟ وسؤال شخصي من وين حضرتك حابين نعرفه؟ شكرا.
أول شيء عندنا جوابك الجواب الأول السؤال الأولاني له شقين. أول شيء بالنسبة للأسفل، على فكرة الميكسينج بلانت إذا في له جود ديزاين وكان في نتخلص من الخبرة لأنه ما فيش في أي ضرر على البيئة فيه، بس عندنا مشكلتنا لأنه الغبر اللي بتطلع منه عادة بتتركوه للجو، ما بيهتمش نفس مشغل المصنع، ما بيهتم في الانفايرمنت فما بيحطها، بس احنا عادة بناخذ المواد اللي بتطلع منه نشفطها من المصنع ونحطها في المية عشان نحاول نجمعها ونعاود ننشفها ونعاود نضيفها، بس هم they don't use this one. خلاص هو المهم عنده ينتج الخلطة. الشيء الثاني هلا في عندنا شيء اسمه وورم ميكس اسفلت، في عندنا اديتيفز بنضيفها على الخلطة الاسفلتية بتقلل لي درجة الحرارة اللي بحتاجها عشان اخلط الاسفلت فيها. بالنسبة لي بعد اذنكم انا اسمي الدكتور إبراهيم عاصي، خريج جامعة الدكتوراه المعاد في السعودية، وبدرس في الجامعة الهاشمية في الأردن، وبعدين أنا بشتغل في المركز العربي للدراسات الهندسية في الوقت الحاضر، وبشتغل كبارت تايم في جامعة عمان الأهلية. شكرا لك.
وما ننساش إنه الرسائل فلسطينية كمان.